Assalamu alaikum, dear student. Today is the video lecture number 2 of week number 4, and we are continuing the chapter number 2, the pressure and fluid static. And in this lecture, the topics we are going to cover today are the buoyancy, flotation, and stability. We will see what is the basic difference between all these three terminologies. And the buoyancy, we will see what it is, flotation, what is stability, and there is further what is stability of a submerged body and what is stability of a floating body, that we will see. So first of all, we will see what is buoyancy, okay, and how we can calculate the buoyancy force, and what is the acting location of the buoyancy force, to how we can determine, that we will study in this under this heading. So what is buoyancy? So according to the Archimedes principle, whenever a body is placed over a liquid, either it sinks down or floats on the liquid. In floating position, the body is subjected to two forces. Okay, this is understood. Whenever we placed a body over a liquid, what happens? Either the body floats over it or it sinks down. But it doesn't happen automatically. It happens because of two reasons. So number one, the reason is the two different forces. One is the gravitational force, and there is a upward thrust due to the fluid in which the body is immersed. Okay, so number one as shown here, the gravitational force W, its weight acting in downward direction, and the upward thrust of the liquid, also called the buoyant force. Okay, so here it is point to be noted down. The upward thrust offered by the fluid is called the buoyant force, acting in the upward direction. Okay, so what happens because of that? In equilibrium position of floating, okay, if the body is either floats or it suspends, because you see, whenever we placed a body over a liquid, what happens? Either the body floats. What is the meaning of floating? The meaning of floating is the body is partially submerged in the liquid or partially above the liquid. So that is basically the floating position. And other is the suspended position. What is the suspended position? That means the body is completely submerged in the liquid, but it is not sinks down. It is not resting at the bottom of the surface of the liquid. Okay, and third position is the sinking. That means the body is completely sinks down. It is no more in the it is resting somewhere on the solid surface. Okay, so in equilibrium position of floating, okay, so in equilibrium position of floating, what happens? If the body is floating on the surface of the liquid, the magnitude of both the forces in the weight of the body and the forces offered by the displaced fluid are equal, and they act in opposite direction along the vertical axis. Okay, so in that case, both the forces you can see here. So this is the floating condition. Okay, and this is weight of the object or weight of the solid body which is acting downward, and this is the force FB, the buoyant force offered by the displaced fluid. Okay, this is the displaced fluid which is offered, and it is holding this weight, and they are acting in the same line of action, same vertical axis. Okay, so this is the equilibrium condition. Okay, So once again, in equilibrium position of floating, the magnitude of both the forces are equal and they act in opposite direction along the vertical axis. Okay, as it is said, the weight is acting vertically downward and the Bion's force is acting vertically upward. Okay, if both forces are equal and opposite, that means the body is in equilibrium position. However, if the gravitational force is more than the upward thrust, so what will happen? Upward thrust of the If the gravitational force is more than the upward thrust of the liquid, the body will sink down. Okay, the magnitude of the buoyancy force can be determined by Archimedes principle, and it is expressed as, okay. So now we can see how we can determine the buoyancy force and what exactly the Archimedes principle says. The buoyant force acting on a body immersed in a fluid is equal to the weight of the fluid displaced by the body, and it acts upward through the centroid of the displaced volume. Okay, so as I showed to you the slide here, okay, here you can see we put a solid body over a fluid, okay, and what happens, then the solid body displaces the fluid till it comes to at rest or come to in equilibrium position. Okay, so what happened, the displaced fluid, okay, offered a buoyant force Fb and hold this weight in equilibrium position. Okay, so this is the center of buoyancy where the force is acting. Okay, if the body is in equilibrium position, the center of gravity and the center of buoyancy will lie on a same line of action, okay, on the same axis. Okay, and this is the center of the displaced, this is the center of the displaced liquid. Okay, and now we are going to find out what is the magnitude of this buoyant force, how we can calculate the magnitude of this buoyant force. So let's say, so here we said that what is the Archimedes principle, the buoyant force acting on a body immersed in fluid is equal to, okay, so what is the buoyant force is equal to weight of the fluid displaced by the body, okay, and it acts upward through the centroid of the displaced volume, as I showed to you just now. So now we are going to determine the magnitude of the buoyant force. Okay, so let's consider the buoyant force is caused by the increase of pressure in the fluid with depth. Okay, so as you know that as you increase the depth of the liquid, the pressure will increase on the surface. Okay, this is we have already proved that. Okay, if you go further down, the pressure will further increase. Okay, so consider, for example, a flat plate. This is a flat plate of thickness h. Consider the thickness of this flat plate, it is h. Okay, submerged in a liquid of density rho, parallel to the free surface as shown in the figure. Okay, this is our free surface. Okay, so you already know what is the free surface, and this body is parallel to this surface of this body is parallel to this free surface. Okay, and the density of the liquid is rho, then rho f is the fluid density. Okay, as shown in the figure. The area of the top and also bottom surface of the plate is A. So area, because this is not a regular shape, but we are saying the area of the bottom surface and the top surface are A, as its distance to free surface is h. Okay, and the distance from the top surface to the free surface is s. Okay, I mean this is the depth of the fluid up to the top surface of the object. The gauge pressure at the top and bottom surface of the plate are. So you know that what is the gauge pressure? We derive the equation P is equals to rho g h, yani density of fluid into gravity into h. Okay, so now we are going to find out the on the top surface are the pressure on the top surface are rho into the rho of the fluid into g into s. Okay, so this is the pressure for this is the pressure on the top surface, excuse me. So this is the pressure rho of the density of the fluid into gravity into s equal to h. This is the force, this is the pressure, okay, acting on this surface. If you multiply this pressure with a, so this will become force. Okay, so this is the force acting on the top surface. Now what is the magnitude of the force acting at the bottom surface? That is, the height at the bottom surface is h plus s. So what is the pressure? Density of the fluid, gravitational acceleration into s plus h is the depth. So this is the pressure acting on this, because you know always the pressure acting perpendicular to the surface. The bottom surface, the direction will be opposite. Okay, so this is the force acting at the bottom surface. Okay, the s plus h into, and if you multiply it with the area, you will end up with the pressure force. Okay, and there is a okay, respectively, then the hydrostatic force top is equals to this, because if you multiply it with the area, this pressure become the pressure force. Okay, and same the pressure force at the bottom. Okay, so what is the buoyancy force? The buoyancy force is the difference of the pressure force at the top and at the bottom. Okay, so buoyancy force, take the difference bottom minus top. Okay, so just add those values. The bottom force we calculated this, and the top force we calculated equal to this. Okay, so here to rho okay, you end up open up, so this part and this part will be cancelled, only rho f g h a will remain, and this h into a will be equal to the volume of the object. You see the thickness of the object is h and the area is a, so what is the volume of this object is v. So the buoyant force will be equal to the density of the fluid into gravitational acceleration into volume. So we can express that. Okay, and what is the position or acting position of buoyancy force? The point through which, okay, the point through which the buoyant force acts is called the center of buoyancy. Okay, the point through which the buoyant force passes through it, it is called the center of buoyancy. So now let's move on to the other slide. Okay, so as I said earlier, volume is equals to h into a is the volume of the plate, but the relation rho f gv is simply the weight of the liquid whose volume is equal to the volume of the plate. Okay, so this is the because density, gravitational acceleration, and v, so this is the volume of the fluid displaced by that solid object. Okay, so simply we can say that the weight of the liquid whose volume is equal to the volume of the plate. Thus we conclude that the buoyant force acting on the plate is equal to the weight of the liquid displaced by the plate. Okay, so whatever is the shape of the object, okay, the buoyant force will be equal to the volume displaced by the shape of that object. Okay, so note that the buoyant force is independent of the distance of the body from the free surface. Okay, it is also because there is no S. Okay, the equation we derived here, you see, what is S? S is the depth of the fluid. So there is no S in the Bion's force equation. Okay, it is only the Bion's force depend on the volume of the object and the density of the fluid. As the density of the fluid and the shape of the object will vary, the volume will vary. This volume is the display volume of the displaced liquid. Okay, display will vary, the Bion's force will vary. Okay, so the Bion's force depending on the density of the fluid and the volume of the displaced fluid as well. So note that the Bion's force is independent of the distance of the body from the free surface. It is also independent of the density of the solid body. And also you can see in that equation we cannot see the density of this solid body. Okay, we are seeing the density of the fluid only. Okay, so that means the Bion's force are depending on the two factors. So finally, according to the Archimedes principle, we can say that the buoyant force acting on a body immersed in a fluid is equal to the weight of the fluid displaced by the body, and it acts upward through the centroid of the displaced volume. Okay, so this is all about the buoyancy and Bion's force. So let's move on to the other topic, that is called principle of flotation. So under the heading of flotation we will see what is flotation and what are the conditions of flotation. So here it is mentioned, the floating bodies are a special case. Only a portion of the body is submerged with the remainder poking up out of the free surface. Okay, so this is the case. In the case of flotation, part of the body is underwater and part of the body is above water. In that case, the buoyancy force will be equal to the weight density of the fluid and the displaced volume by the solid object. Okay, so hence the principle of flotation is a floating body displays its own weight, okay, in the fluid in which it floats. Okay, so this is the whole, the weight of the body is displays the fluid equal to its weight. Okay, so here we can say that the weight of the object, in the case of flotation we can say that weight of the object is equal to weight of the liquid displaced by the immersed portion of the object. Okay, so this is basically the condition of flotation. So here we can see further here we are going to find out the condition at which the body floats, the body suspends, and body sinks down in a fluid. So let's see how we do that. For floating bodies, the weight of the entire body must be equal to the Bion's force. Okay, which is what is the Bion's force? Bion's force is the force offered by the displaced fluid. Okay, which is the weight of the fluid whose volume is equal to the volume of the submerged portion of the fluid body. That is, any Bion's force is equal to the weight of the object, the complete weight of the object, and this force is offered by the displaced liquid. So FB and W are equal. So what is FB? This is the portion volume of the fluid, because you say this is not the complete, this is the complete volume of the object, but the surface which is displacing the fluid is balancing the whole weight of the object. So this is density of the fluid, and this is the portion, this is the submerged portion of volume. So this is the submerged portion of the volume up to here. Okay, so this is the volume of submerged portion, okay, equal to the weight. Okay, So what is gamma? Gamma is basically the rho f, density of fluid into gravitational acceleration into submerged volume of fluid, is equals to weight, and this is the density of fluid, gravitational acceleration, volume of submerged fluid. What is submerged volume? From here to here is the submerged volume. Okay, and this is the average density of the body. Okay, this is the average density of the body. Maybe it's made of a two different metal, maybe three metal, the object we don't know, just like a ship. In the ship we can see there is a wood, there is a metal, there is a lot of things it carries. So we are considering a average weight of the solid object, gravitational acceleration, and total volume of the body will give you the weight of the object. Okay, so this is the weight of the object. So here we just see gravitational acceleration is going to cancel out, so V submerged over V total of the object, and average density of the body is over the density of fluid. So this is the final relationship we end up with. So if this is equal to 1, so here we can say therefore the submerged volume fraction of a floating body is equal to the ratio of the average density of the body to the density of the fluid. Okay, so this is the ratio we can explain in this way. Now there are different cases basically appears with this relation. Note that when the density ratio, this is the density ratio, is equal to or greater than 1. Okay, if the density ratio is equal to 1, what is the condition of equal to 1? When this whole body will come under water. Okay, so if this part is becoming 1 or greater than 1, then what will happen? When the density ratio is equal to or greater than 1, then floating body becomes completely submerged. So let's see in the next slide. So here are the condition of floats, suspends or sinks. So let's see what are the conditions that we drive an equation in the previous slide. So based on that we conclude our discussion here. Okay, so now we are going to see the conditions of floats, suspends and sinks. So what are the conditions? It follows from these discussion that a body immersed in a fluid, consider a body immersed in a fluid. So number one case, if a body immersed in a fluid remains at rest at any location in the fluid, where its average density is equal to the density of the fluid. Okay, so if this is the case, if the density of the fluid is equal to average density of the object, so what will happen? It will not sink down, it will move within the liquid. It will not submerge, it will move within the liquid. Okay, so this is the case when the densities are equal. So now case 2, a body immersed in a fluid sinks to the bottom when its average density is greater than the density of the fluid. Okay, so this is the density of the fluid and this is the average density. If the average density is greater than the density of the fluids, what will happen? The body will sink down, it will rest at the bottom. Okay, so this is the second case. So now third, a body immersed in a fluid rises to the surface of the fluid and floats when the average density of the body is less than the density of the fluid as shown in the figure. So here you can see this is the third case, the density of the fluid is greater than the density of the average density of the object. So in that case the body will float. Okay, so these are the three conditions that we drive with this equation. Okay, and we can conclude our discussion about the flotation, suspends and sinks of an object in a fluid. So let's move on to the other topic, that is stability. So what is stability? Stability and an important application of the buoyancy concept is the assessment of the stability of immersed and floating bodies with no external attachments. This topic is of a great importance in the design of ships and submarines. Okay, so basically these are the concepts. Okay, the concepts of buoyancy we apply in two major applications. So let's not only this and some other applications as well. So let's see what is stability. So let's understand what exactly the stability. When we talk about the stability, what does exactly it means? So stability means the stability characterizes response of any object to a small disturbance like air or wave in oceans. Okay, so there are three conditions of stability: the stable objects, unstable objects and neutral objects. So what is stable objects? When a small displacement from equilibrium will result in restoration to original position due to righting movement. Okay, so consider here there is a equilibrium position. If I disturb from here to here, okay, if I disturb this ball from this position to this position, I disturbed it. Okay, so what will happen when I release it? So what will happen? There is a returning movement. Okay, it will move, go back and forth, and finally it will come back to its original position. So such restoration movement, because of this restoration movement, it will retain its original position. Okay, such conditions are called stable condition or stable objects. Okay, unstable objects, a small displacement causes the body to move further from its original position due to overturning moment. So in this case, if I give a small disturbance, what will happen? The body will go farther away and it will never able to come back to its original position. Okay, because of this overturning movement. Okay, so this is unstable condition or unstable objects. There is a neutral object. A small disturbance do not create any additional force, and so the body remain in the disturbed position. So in that case, this is the horizontal surface. If you disturb this ball, what will happen? It will move in the same direction, but it will never come back. It will remain on this axis, but it will not come back ever on this position because there is no returning movement on applying on it. Okay, because of this disturbance. So let's move on to the other slide. So stability, now we are going to apply these conditions of stability in our real cases. Okay, so now we have studied two things: submerged body and the floating bodies. So here we are going to discuss about the stability of a submerged body. So what is the importance of stability of a submerged body? So we can see the submarines underwater, they are completely submerged. Okay, the object which is completely underwater is called submerged body. So submarine, if it do not maintain the stability condition, it will flip out. Okay, so let's see how do we maintain the condition of stability in the submerged body. So the stability of a submerged or floating bodies depends on the relative position of the buoyancy force and the weight of the body. Okay, the buoyancy force acts through the center of buoyancy, which is coincident with the center of mass of the displaced fluid. Okay, the criterion of stability of a submerged body, okay, balloon or submarine. We have seen balloon on the water. Whenever you visit the sea, you will see a big balloons over water. Okay, the criterion of stability of normally they hook up the ships with those balloons. The criterion of stability of a submerged body, balloon or submarine, is that the center of buoyancy B must be above the center of gravity or the center of mass of the body. Okay, so here this is important point to be noted down. The criterion of stability of a submerged body, okay, the balloon or submarine, is the center of buoyancy B must be above the center of gravity or center of mass, okay, CG of the body. A special case will be of neutral equilibrium, where the center of gravity coincides with the center of buoyancy, for example fully submerged homogeneous bodies. Okay, so now let's see the condition of stability in a submerged body. So here you can see this is the case of a stable submerged body. Okay, this is a stable submerged body. So what is the condition of stable submerged body? As I said to you earlier in the previous point, okay, the condition of stability is the buoyancy force must be, the center of buoyancy must be above the center of gravity. So let's see here the condition. Okay, this is the this is a balloon. Okay, this is a balloon and it is heavier from the bottom. Okay, and this is lighter from the top. Okay, so this is the weight of the object which is acting downward, because the more mass is here, you can see the more mass is here, the center of weight or center of gravity is acting somewhere at the bottom of the balloon. Okay, and this is the center of buoyancy, this is the center of the displaced fluid. What is the center of buoyancy? It is the center of the displaced fluid, okay, where the buoyancy force is acting. Okay, so consider an example. For example, consider the completely submerged body shown in the figure. This stable, we are talking about the stable condition. What is the condition of stability of a submerged body? This body has a center of gravity below the center of buoyancy. The center of gravity is below the center of buoyancy. Okay, a rotation from its equilibrium position will create a restoring couple formed by the weight and the buoyancy force FB. Okay, so we give a small disturbance. Okay, if I give a small disturbance, so what will happen? Body will come to this side. So how these forces will react? So definitely what will happen? The weight, the position initially, both are acting in a same line of action. Okay, the centers are same, the center of gravity and the center of buoyancy are acting on a same line. But when we disturbed it, what will happen? This will act like this and this will act like this. Okay, but the direction of the force will remain same. So this is the direction of the force acting downward, this is the direction of the force acting upward. Okay, so what will happen? So because of that, it is if you disturb this object from this position to this position, okay, so consider there is a wave which disturb this this object. Okay, so what will happen after this disturbance? Would this object will regain its position or not? So then how it will regain automatically without influence of the external force? So we can see once we disturbed it, so this force acting at the bottom, this is acting in the upward direction. So what will happen? There will be a restoring couple. How? Take the moment. Okay, just see. So if this is the center, okay, this is the center, if this is the center, so it will take the moment this side, and this will also create the movement this side. Okay, so there is a restoring couple in this direction. So what will happen, this will overcome this disturbance and it will regain its original position. This we are saying here, a restoration from its equilibrium position will create a restoring couple, because if this is the center, because this is the because how we take the moment, force into perpendicular distance. So if this is the center, the force will go to its origin and this will also go to its origin. So there will be a restoring couple in this direction. Okay, so it will help to regain its original position. So a rotation from its equilibrium position will create a restoring couple formed by the weight and by the buoyancy force, which cause the body to rotate back to its original position. Thus, for this configuration, the body is stable. Okay, so now the other thus for this configuration, the body is stable. It is to be noted that as long as the center of gravity falls below the center of buoyancy, okay, so this is the center of buoyancy, this is the center of gravity. So as long as the center of gravity falls below the center of buoyancy, this will always be true. That is, the body is in a stable equilibrium position with respect to a small rotation. Okay, so now the stability of a submerged body, this is the case of an unstable condition. Okay, so in that case, now consider the completely submerged body shown in the figure. Okay, unstable. So this body has a center of gravity above the center of buoyancy. Okay, here the upper portion of the body has a bigger weight and the bottom portion has a less weight. So in that case, the center of gravity will lies on the top. Okay, and the buoyancy force, that definitely it is the displaced, it is the center of the displaced liquid, displaced fluid. Okay, where the buoyancy force is acting. So it is below the center of gravity. So what will happen if we give a small displacement? Okay, if we disturb it, so what will happen? This body has a center of gravity above the center of buoyancy. The resulting couple, overturning couple formed by the weight and the buoyant force, will cause the body to overturn and move to the new equilibrium position. So what will happen? You see, if we disturbed it, so this is the buoyancy force and this is the weight. So this is the center. If you take the moment across this center, between these 2 points there is a center point. So force into moment, so it will create a moment in this direction, and this will also, this is the center point, this will also create a moment in this direction. Okay, so that means there is a overturning couple which will never bring it to its original position. So it will go to another new equilibrium position. Okay, so this is unstable condition. Thus a completely submerged body with its center of gravity above its center of buoyancy is an unstable equilibrium position. Okay, so whenever the center of buoyancy below the center of gravity, the body will be unstable. Okay, in case if there is a small disturbance applied on it. Okay, so now we are going to talk about the stability of a floating body. If the body is floating, the body is partially up and partially submerged in the liquid, then how the body can be remain in a stable condition, and at what condition the body will be unstable and it will sinks down. So, and also there is an important concept of a meta center we will discuss. Sorry, I think this topic is will take some more time, and I don't think I have enough time to complete this topic in this lecture. So we will discuss in the next video the stability of a floating body and the concept of a meta center. So today I am ending up my lecture at this point. Okay, Assalamu alaikum.